Welcome. Today's class is Engineering Mechanics, class number 71, type of loads. Today's class is we are in type of loads, we are in part 2, equilibrium, types of loads and support reactions. Equilibrium already over in part 2, lecture 1 to 19. From lecture 20, I started types of loads. Already 20 to 29 are uploaded here. See, you can see here. Already over 20, 29. I will explain. Today's class is 30. That is for type of loads. It is a concluding class. See, this is concluding class for type of loads. I write here now. Actually not required. This is concluding class. Concluding class for types of loads. I will tell you why I am explaining so much. There is a reason. Okay. This class is very, very important. I will explain why important. And remember, all you can remember, this class has all in one with further more important concept. Now, what is that all in one? I will tell once again. See. First I will tell, when I started type of loads, lecture 20-29 already over, I first told some introduction, some explanation for distributed load, etc., how to find the total load, how to locate centroid, that all I told. Then I started part 1, part 2, part 3, part 4. Part 1 is for concentrated load. There is nothing there. Part 2 is for UDL. See, loaded length is L0. Or part 2, part 3, part 4 are all for distributed load, where there is loaded length called L0. See, in all these cases, loaded length means from where load starts, from there distance to where loading ends. See, correct, clear. Loaded length L0. For uniformity, I maintained left side A, right side B as loaded length everywhere. Then from A to left side, I took a random point C, distance x1. Every place I am not writing. Some distance x1. From B, some distance x2 to right side. Okay. Everywhere same. See, here also x1, x2, x1, x2, x1, x2. Sometime numerical. Now, part 2 is for uniformly distributed load. Part 3 is for uniformly varying load represented by a triangle. There 3 cases are there. Case 1, part 3, case 1 is UVL represented by a right angle triangle. Case 2 is UVL represented by an isosceles triangle. I have not written here. See, these are equal. And part 3, case 3 is UVL represented by a triangle in general, where, see, randomly goes. This is smaller, this is bigger. I took one more case. Left side bigger, right side smaller. Now, this is nothing. Don't worry about this one. Point load. Point load is no problem. Then, in all this part 2, part 3, part 4, that is entire distributed load. See, for all this one, earlier lectures, 20-29, you can see part 1, part 2, part 3, part 4. What I explained is how to find magnitude of the total load. I told repeatedly, your hand should move like this. Total load. If it is a numerical, if it is kilonewton and meter, it should be kilonewton, not kilonewton per meter. Total load. How to decide direction? Direction is clear, everywhere downwards, leave here. Then, how to locate line of action of the total load? Everything for, very important, entire loaded length. See, full loaded length L0. Everything is for entire loaded length of L0. And also then, how to find moment of that total load about two extreme ends of loaded length, A and B. Here, everywhere A and B. And also, how to find moment of the total load about a point which lies outside the extreme end, one point left side, how to find moment about C, how to find moment about D. These all thoroughly over. Now, very, very important, I'll explain in the class. What is all-in-one means? Today's class, with numerical part, all these will come once again. But remember, which already over earlier, I will write here. Suppose something, this I'm explaining. I will write already over earlier. Difficulty means refer part 3, case 3. I will write this way. Which I told already earlier, that I will briefly tell. I will not explain much. Already lot of explanations are given, but I won't waste time on that one. But to see that everything is in compact form. For loading, whatever you require in future, class number 30 is critical, but class number 30 supported by lecture number 20 to 29. Supported by. So what you have to do, you are advised, first thoroughly study lecture number 20-29 very thoroughly, master it, then come to class with lecture number 30. See how easily you can master the concept. See, now I will tell you why it is important. Someone will tell, if you are telling everything once again, why you require? It is already told in detail. No, there is some further more important concepts are there. I will dictate briefly here now. When we find shearing force and bending moment in SFD BMD, and also that, see, once you go to strength of materials and start SFD BMD, shear force and bending moment, then it will never leave you. When you go to structural analysis or bending stresses, deflections, etc., or later when you go to structural analysis, any chapter, rolling loads, ILD, arches, cables, strain energy method, slope reflection, moment distribution, Carney's method, whatever you tell, everywhere SF and BM will come with you. It will follow you. Wherever you go, it will tell I am there. Therefore, full structure analysis, that SF BM will come. And now remember, when you find SF and BM at any point or any section, means any point you will tell in a beam. Suppose somewhere here, anywhere, or somewhere here, what you have to do? You have to consider only one side. That all will come later. See, when you consider equilibrium, algebraic sum of moment, you have to consider the entire loading. But when you find SF or BM at any section of a beam, then you have to consider loading only from one side, whether either to left side or to right side. I will tell you later which side to consider. Whichever side is easier, you consider. Irrespective of whether you consider this side or that side, answer will come same. My guarantee is there. It will come same. But at that time, see, suppose you require SFBM, make a note, somewhere outside the loaded length, then there is no problem. See, suppose loading is somewhere there. You want SFBM here. If you look this side, you cannot see the loading. If you look this side, you can see full loading. Yes, already covered here. See, about a point C, outside point. But if that point lies somewhere in the loaded length, see, I'll tell you here. I will mark the point as Q. For understanding purpose, I will mark here. Somewhere Q. Somewhere Q. Here two Qs are there. One Q here, Q1. One more Q here, Q2. Again, one Q, Q1 here. One more Q, Q2. See? Q1, Q2. I forgot here. Part 4 is for uniformly varying load represented by a trapezium. I forgot to tell you. Okay, then see here. Somewhere here Q, somewhere here Q. Then, when you want SF or BM there, you have to look only one side. Then, full loaded length will not be considered. Loaded length considered will be, if you look this side, whatever is the length this side, loaded length this side. Or if you look this side, whatever loaded length this side. Then you require one total load that you require for shearing force calculation. Shearing force you require only load. Then you require for bending moment of that load we always want about Q, about that point Q. About Q only want, of course here two Qs are there, that Q will be always within the loaded length. If it is outside, there is no problem, already over. Now that I am going to cover today. But what I will do is, today's purpose of the class is that intermediate point Q. But what I will do is, when I cover that one, each case, for each and everything I am covering now, see, this requires infinite patience. I got the patience. My purpose is to teach so that everybody gets good education. Once you realize that one, you will follow correctly whatever I tell. Therefore, what I will do is, for each and every case, as a recap, I will cover what is done earlier. That is, about that earlier, that I will cover whatever is already over in part 1, part 2, part 3, part 4. That I will not explain here. I will tell, refer, see, this way. Already over earlier in part 3, case 3, like that. By that, before you come to this class, I told you, you first master and perfect, get perfection there. So therefore, I will start now one by one. One by one I will start. Now, before, when I start here, first you require for one by one now. See, I will remove this one now. Because that point load, there is nothing. I don't want to waste time on point load. Therefore, I will start here now. See, all I will remove. First, one by one. Actually, point load, this problem is not coming because there is no loaded length. Still, for make more clear, I will start here. First, concentrated load. See, concentrated load. All numerical today, load or point load. Point load. Briefly, I will tell something. See, suppose you see here, you apply a load here, 40 kilonewton, a point ABC. Now see, this ABC is not ABC. There is no loaded length here. Imagine this distance is 4.1 meter. This distance is 5.2 meter. Okay. Now, what we want? We require magnitude of the load. For distributed load, we require magnitude of the total load for loaded length considered. See how many times I wrote it. But here, there is no total load. There is only one load is there. So, directly, magnitude of the load equal to 40 kilonewton, direction down. Then, line of action of this load passes through B, see B here. Then we want moment of that load, moment of this load about, I want about A, little later I want about B, little further later I want about C. See here. And I told so many times for you, when you find moment for distributed load, I always told bracket into bracket. See, this way, right? This is the magnitude of the total load. This is the distance. This is moment into. Point load, bracket is not required. Directly, moment about A, 40 into 4. 40 into 4 into kilonewton meter. It is a clockwise. See, clockwise. Moment about B, 0, because moment of any load about any point which lies in its line of action is 0. Moment about C is 5.2. Okay. 40, no plus minus today. See, there is no sign convention. If it is clockwise, I will write clockwise. If it is anti-clockwise, I will write anti-clockwise. When you go for SFD-BMD or say equilibrium, there you consider sign. I will tell you. So this is 40 into 5.2 anti-clockwise. Kilonewton meter anti-clockwise. Over. If anybody has got difficulty for this one, I will tell, refer part 1. Someone will tell. If someone really go to part 2 and refer, I think not fit for studying. If this is not clear, then nothing will be clear in structural engineering. Okay, now I will go to next UDL, part UDL, etc. One by one. In order, I will start. It's a very lengthy class. I am recording in installments, means part by part. That's why there will be a delay in uploading the class. Maybe some 3-4 days required. Because the single day I cannot do everything. Slowly I will do part by part. Okay, I'll continue. Okay, now come to example one by one. Example 2. I forgot. Just now I finished one example for point load. You make it previous one, you make it example 1. See, some load I told, I don't remember how much I told. Who will remember it? That you make example 1. See, I will give number so that example 1 is part 1. Example 2 is part 2. I will maintain the same sequence so that all you have to do is, if any confusion is there earlier, you have to go to respective part. Okay. Example 2. You can make a note here. See, and one more thing I will tell now only. Through this is a very lengthy class. Each and everything writing takes lot of time. So sometimes, see, I will dictate. You should clearly write. See, suppose I will only once I will write now. Next time I will dictate. But you should not write dictate there. See, example 2. You can make here note. This is for UDL. Okay. Consider UDL of 60 kN per meter for a loaded length of 7 meter between A and B. Just outside A, left side, consider a point C at 3 meter. This side outside D at 2.5. Earlier some other example. Okay. Now, first you write the sketch. That's all. Do not write anything in the sketch. I will tell you why. When you read later, sketch should be clear. You can put a 7 meter here only if you want. Red color means loaded length. Okay, first you write the sketch. But I need not do that way. Okay, sketch over. Now, write one more sketch. There mark everything. Now see, what you want? Magnitude of the total load. See arrow mark here. Now I am writing. Next time when I put this way, I will tell what you have to write. Magnitude of total load for entire loaded length of how much? 7 meter equal to numerical value 60 kN per meter for 7. Y means no answer. I already told you for UDL total load is always equal to kilonewton. This is downward. Okay. Next. One more statement you have to write. Oh, sorry, I already wrote here. See. Okay. Now, I wrote there, once again wrote here. See. Magnitude of the total load, you write there for entire loaded length of 7 meter is 16.7 kN. Line of action of this total load will pass through center of loaded length, that is at 7/2 from here and 7/2 from here. Light line you have to write. Okay. Put one sketch. Okay. Over. Now draw one more sketch where don't write 7/2 all. This is for understanding only. Okay. Start now. Moment of this total load about A is total load. 60 into 7 is the load. See, I told you 60 into 7 is the load. 60 into 7 into 7/2 clockwise. Moment about B. Again total load 60 into 7 into 7/2 anti-clockwise. Moment about C. 60 into 7 is the total load into 3 plus 7/2 clockwise. Moment about D. 60 into 7 is the load into 2.5 plus half of 7, that is anti-clockwise. All are in kilonewton meter. All are in kilonewton meter. Do not see that side. Don't see that side. I have not come there. Okay, now, right, up to here, already over in part 2. Therefore, if you get any difficulty or doubt, there I took nearly 30-40 minutes how to find moment about extreme ends of the loaded length or outside point. You should refer earlier class. Now our important. Okay, now all this over now. See, now right here. Now come here. Now, purpose of this class. The very purpose of this class, very, very important, I told you. Suppose we consider a point, say Q, some random point Q. I will tell where is the point Q. Some random point Q, somewhere in between the loaded length. That is, as per class example, somewhere in between A and B. Don't by heart A and B. Somewhere in between loaded length. And we have to find magnitude of total load considering loading to only one side, not both sides. That is of that point. That is either to left of the point. You should write, that is, if you write further here, considering loading either to left of that point Q or considering loading to right of that point Q. That much you can add. That is, I written here, considering loading I written here. And that magnitude you want separately, and also we want how to find moment of that total load. With total load, once you consider only one side, that one side load. About Q only you require, other point you never require. When you, in structural analysis, you want only Q, about Q. Now, let that point Q be at, this is 7 meter, some random distance. Center I will not take anything, not 3 meter, 3.1 meter, okay. Be at 3.1 meter, red color, because a new point. Be at, this is my choice, 3.1 meter, I will take from A. From A, okay. Now, then go there. Where? Come here. Come here. Now I have to remove this sketch and prepare the next sketch. Okay. I told come here. Okay, see. This total loaded length is 7 meter. Now 7 meter will not come. Make a note that 7 will vanish. If you want, remember, already over. This fully 7 meter. They want a point Q. See, somewhere here. Q. Where Q? 3.1 meter from A. If this is 3.1 meter, from here it will be 3.9 meter. Why means, sorry, I can't answer. Then, now see. Now what I told already. What once again I will tell, next time won't tell. Write once for all. Two cases we want, two calculations you require. Calculation 1. Come here, you write it. Look only this side, nothing that side. That is loading from A to Q, that's all. So loaded length will become 3.1 meter over. Find what is magnitude of that total load. And where is line of action from Q? Because why? Because we want moment about Q only. And then moment about Q will be the total load into this distance, whatever you decided. Then look this side, separate calculation. Look this side. See loading only this side. 3.9 meter is the loaded length now. Don't see that side. What is the magnitude of the total load? And where is the line of action from Q? Then what is the moment of that load about this point? When you write moment, you don't use sign convention. If it is, you write this way or this way. When you look this way, see, this way or this way. Here, this way or this way. Later, this way, all I will tell for bending moment. When you do bending moment, it is foolish to consider clockwise, anti-clockwise. So many people are doing it, let them do. They will realize the mistake one fine day. Okay, start now. Now I will not tell once again. Remember, two separate calculation. Once again, I will tell you, when you look this side, don't see that side. You just imagine somebody wants y. Y means no question today. Y means you write the answer. We require later. In structural engineering, we require later for the SFBM calculation. So once look this side, finish. Once you finish, look this side. Don't club those two. Do not club those two. Okay, start. Considering loading only to left of Q, that is, see, this is your loaded length now. Magnitude of the total load equal to, I written here, 60 into 3.1 kilonewton, down. Line of action, this is 3.1 by 2, I written here. And moment about Q is total load. 60 into 3.1 is the load, into 3.1 by 2, this way. I won't tell anti-clockwise, clockwise, this way. For bending moment, it will be negative later. Right. Now, once over, see, you should not do this way, I can do it. Once again, now considering loading only to, this liberty is not there for you. Right of Q. Magnitude of the total load equal to 60 into 3.9, down, over. Line of action from Q is 3.9 divided by 2 meter from Q. And moment of this load about Q equal to 60 into 3.9 is the total load into 3.9 by 2. It is clockwise. See, not this way. See, when you do sigma m algebraic sum of moment for equilibrium, you take clockwise, anti-clockwise. When bending moment is there, last time it came like this, negative. Now it came like this. This also negative, because there hogging, sagging. So you never bother about sign convention. You write, don't use clockwise, anti-clockwise. You write, if it is this way, or I can tell clockwise, anti-clockwise. Right now, clockwise, anti-clockwise. Later, I will tell you should not use clockwise, anti-clockwise. But, or later, see, it is like this, over. Anything mistake? No mistake. Okay, this will complete the UDL part 2. Now I will go to example 3, that is UVL. Remember, 1, 2, 3, 4, 5 problems are there, very lengthy. It will take more than 1.5 hours, I know it. Okay, with infinite patience, I will cover each and everything so that those who use this class, it is a lifetime for them, reference. It will be lifetime reference for them in future for SF and VM or any, in future, anywhere when they require. Don't see this one now, that later. Start. Next. Example 3. Remember, example 3 is for part 3. 1 dot is for case 1. A is, there are 2 examples are there. One this way, one this way. That's why part 3, case 1, you see the classes there. And A. Or don't buy all these numbers. Consider uniformly varying load represented by a. Now remember, example 3 is fully for UVL represented by triangle. There are how many parts? 3 parts are there. Okay, now start. Varying load, 0 at left end, maximum at right end, this way, right angle triangle. Okay. Loaded length 7.5, 1.6 here, 1.8 here, randomly. See now, start. Magnitude of the total load considering the entire loaded length, full loaded length. See, it will be here. This is the total load, thousands of times I told. Total load over. How much? Equal to half into 7.5 into 50, I wrote here. If you want, you can write there also, once again. Then, line of action of this load from here, see, is for this triangle, 2 by 3 of 7.5 meter. From here, 1 by 3, light line, 7.5, I written here. 1/3, 2/3 from here, 1/3 from there, I wrote. Now, moment about A. Total load, half into 7.5 into 50 is the total load into 2/3 of 7.5 clockwise. Moment about B, same total load into 1/3 of 7.5 anti-clockwise. Moment about C, once again the same total load into 1.6 plus 2/3 of 7.5 clockwise. I written there. Moment about D, same total load into 1.8 plus 1/3. Remember, all moments are in kilonewton meter. I know unit, don't bother. This class is not for unit. Okay. This is part 1. Now here, come here. If you want to understand the subject, this statement write once again. Good for health. Then it will be clear. Suppose you write in one question, next time you think, who will write all these? Once in a lifetime, write it. Same story. Let the point Q be at not 3.1 now. I will give distance, it's a multiple of 3. So that change will not come. 4.5 better. 1.8, 5.1, 3.9. 3.9, okay. Some random number. 3.9 meter, randomly. 3.9 meter from A. Okay, now, then, okay, I have to prepare. Now is the purpose of the class. Start now. Now come here. Now, once again you have to write purpose of this class. All I told about you, one point Q required. Now I won't repeat. I told Q will be at 3.9 from A. There is one small problem. I wrote this much and rubbed everything. Then I faintly remembered loaded length was 7.5 meter. I started recollecting. And the maximum was 50, I think. Somehow I remembered. I forgot to make a note somewhere there. In the next question, I made a note. What happens is, if I want to see exact values, I have to stop the recording, again see the recording there and observe it. Then my setting will go. The camera is set correctly for the board. So once I go for seeing the recording there, the setting is gone. So I will do one thing now. So therefore, make a note. I think it is 7.5. So make a small note. Most probably, the question given is like this. See here. This is A, this is B. I think it is 7.5 meter. And this is 50 kN per meter. Most probably, that is the answer. Now, by chance, it is different. Do one thing. I can't change it now. Change the question. Make 7.5 and 50. Then I will tell once again, earlier, which is already over earlier, for the entire loaded length, total load, half into 7.5 into 50. Moment about this point. Half into 7.5 into 50 into 2/3 of 7.5. About this point. Half into 7.5 into 50 into 1/3 of 7.5. About this point, this distance plus 2/3. About this point, this distance plus 1/3. You change it. I cannot say recording once again. Now I will be careful because I am very weak in remembering. I am very weak in remembering things all. Not concept actually, this numerical all I cannot remember. So now it stands at 50 kN per meter for 7 meter. Okay, now remember 7.5 meter. See, I told 7.5 meter. Now that 7.5 is no more there. Now do one thing. See now, correctly write. Now fair copy. If you want, write a rough sketch. Rough sketch here. See. Now the point C and point D will not come. This is A, this is B, this is 50 kilonewton per meter. Total loaded length is 7.5 meter. We are asked to, that point I want at 3.9. So somewhere here, see. Somewhere here is a point Q. The distance of Q from here they told 3.9 meter. 9 meter. Now, see, here there is a intensity here. Here 50, here 0. let it be W suffix Q. Small w is the intensity at the point Q. Then do one thing. You can see this diagram only. From similar triangles, WQ divided by 3.9 equal to 50 divided by 7.5. Use similar triangles and get WQ 26 kN per meter. Calculate and enter the answer. Let me check the answer once. 50 divided by 7.5 into 3.9. Oh, calculate is not on. 50 divided by 7.5 into 3.9 is 26, correct, 26 kilonewton per meter. Now, this much over. I remove this one now. Now, next question onwards, these similar triangles, I will dictate in the class. I won't waste time writing because space is very precious here. So many things I have to write. So, this space is precious. So, you do the calculation and enter. Now, go back and enter there. See, correctly now procedure. A is here, B is here, our point Q is here. Now remember, if you see left side, you can see a triangular load. If you see right side, you can see a load represented by a trapezium. Okay, this is my dot, 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 dot. Now, correctly write. Now I won't waste time. What we want today's class, suppose a point Q comes in between, I am telling really last time, how to find total load considering only this side loaded length, and how to find moment of that load about this point Q. And also, suppose you want total load to this side, then consider loading to this side of this one, and moment of that total load about Q. So make a note. Now onwards, I won't waste time. If you consider left side, your loaded length is 3.9 meter. If you consider right side, your loaded length is 3.6 meter. When you see 3.9, don't see 3.6. When you calculate for 3.6, don't see 3.9. Okay, now, light line mark here. For this load, see, this is a total magnitude of total load will be somewhere here. See, this is the magnitude of the total load. Triangle. So, considering loading to left of Q, magnitude of the total load equal to half into 3.9 into 26 over kilonewton down. Now right here, I am dictating. See, time is not there. I am dictating. Line of action of that load from the point Q we want. See, we want only from Q. Because why? Because we want moment about Q. From Q, that distance is 1 by 3 of 3.9. Light line right there. Over. Now, moment of that load about Q equal to the total load half into 3.9 into 26 into 1 by 3 of 3.9 this way over. Left side is over. Come to right side. Now, you make a note. When you find bending moment, this I won't tell next time onwards, you have to look only one side. Which side is your choice? So, a person who want to solve fast, I think surely he will look left side. Why? Triangle. If you look right side, you can see trapezium, some complications. Okay, now, same way. For the next question, I won't explain much actually. See, it is like this. When the time comes for the Q point, if you look this side, you get a triangle. So easy. But if you look this side, you get trapezium. So you make a note. So better, this question, suppose you have to look only one side, any side of your choice, if it is your choice, look left side. Here, look right side. But sometimes you will be forced to look right side. What to do? Some reason, that reason we will not discuss here. It will come in shear force and bending moment or design of structures. You will be forced to look that side. No other way. Then you will be ready for this one. Okay, now, considering loading to right of Q. Now, loaded length is only 3.6 meters. See, this load, dot, 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 dot load. Magnitude of the total load, see, it will be trapezium, center is here, slightly this side. Okay, we don't know how much this side. Okay, This is the magnitude of the total load. Total load given by area of the trapezium. This I will not tell because part 1, part 2, part 3, part 4 are not for fun. Actually 9 lectures uploaded earlier. I told the statement not once, not twice, maybe 10, 15 times, not 10, 15, further more times. I told repeatedly there, you don't follow my class, don't go through everything, you study better somewhere else. Okay, start. Now, do not look this side now. Now you are looking here, see, look this side. Total load, 26 plus 50 divided by 2 into distance between them is 3.6. Area of trapezium. Now I will not tell again. When you want the area of the trapezium, that is the total load, sum of the two parallel sides divided by 2 multiplied by distance between the two parallel sides. Last time I am telling. Okay, over. You got total load. Line of action of that one, I can't write values here. Do one thing. You write x bar from Q. See, this is x. Whenever I put x bar in future, it means what? Trapezium. Okay. X bar from here. This x bar from here is, from this side you want, formula is, from where you want, we want from 26 side. That side first, plus, that side plus twice of the other side, divided by that side plus other side, multiplied by distance between the two parallel sides, divided by 3. Therefore, you write here, this x bar equal to 26 plus, see this number, you write separately right here, 26, don't write here, this one only write there, if you want, 26, see this one, 26 plus twice of 50, divided by 26 plus 50, into 3.6 by 3 is the distance. Now moment about this point equal to the total load I wrote here into this distance. This way. Okay. Write all this one. If you want, calculate the answer. Now do one thing. Make a note. Okay. This side I am not disturbing. See, this side I am not disturbing because why? It is triangle only. Or, now see, or I am giving or when you look right side, this distance, I removed the distance only. This is 3.1 meter, correct? No, it is 3.9, I forgot distance only. What is distance there? I. So fast forgotten. 7.5 minus 3.9 is 3.6 meter. So fast forgotten. This is 3.6 meter. You write or, when you look right side, you do one thing, those who are afraid of trapezium, next time I won't tell. What they do is, first you do this much you do. Put dot. Left side hash add right side dot. Okay, now, left side no problem, same. There, mark this way. So, now to understand, see, stagger the arrow marks, light pencil. Okay, now remember this is 26. I won't tell again, 26. This is not 26. This is 50 minus 26. Take a pencil and write there. Take a pencil. 50 minus 24. Why I want calculator? See, this is 24. Light line right here. 24 kilonewton per meter. So therefore, remember, this is 26 only. See, this is 26 kN per meter. Okay, now magnitude of total load equal to, remember, this is UDL, that is right angle triangle. For a triangle, we consider area. For UDL, actually area only, but usually you write intensity first. See, this is actually what? This means the UDL of 26 kN per meter equal to 20, intensity first, 26 into 3.6 downwards is this load plus that load half into 3.6 into 24, 24 is that load. Direction down. When you do shearing force, sign will change. There you decide direction here now. Over. Today we are not bothered about sign convention of shear force bending moment. And moment of this total load, about Q equal to, some will tell, sir, a total load is separately there. Take separate moment. Verigno's theorem. Algebraic sum of moment of the individual forces equal to moment of the total load. Okay, start. Moment about Q. First, this load. How much load? 26 into 3.6 is the total load for UDL into, see, this total load will act here. Exactly center, that much not required, right? Into 3.6 by 2 this way, and also plus this total load will pass somewhere here. Half into 3.6 into 24, half into 3.6 into 24 is the total load multiplied by, from here to here is 2 by 3 of 3.6. Why 2 by 3? I told 1000 times. 3.6. That also clockwise, kilonewton meter. Last time you took trapezium. Now you replaced by rectangle, triangle. What answer you got last time in a single step, if you add these two, you should get the same answer. I am responsible if answer is not tallying. Now, UVL represented by right angle triangle, from left side intensity increasing. When you consider intermediate point, left side you get triangle, right side you get trapezium is over. Now I'll go for example, see, same order. Example 3, 1 dot only. Still case 1, but question number B. Question number B. B is uniformly varying load will come this way. See, it will come this way now. So now, right side you get triangle, left side trapezium, everything explained. So, little briefly I will solve. You take it partially as what? Practice question. But you should work out everything the way I told here. Okay. I'll prepare the question. Then I'll write fast, because why? Starting is not a problem. You will decide. Next question is, see, consider uniformly varying load of this type. Okay, here I noted down there. Why? Otherwise I'll forget later. 16 kN per meter. This is for a loaded length of 10 meter, round number, 10 meter. This is A, this is B. This point is C, this point is D. This is outside, say, 3.1 meter. Random number, whatever comes to your mind I am writing. 2.8 meter. Okay. Now, start first. Right here. Now I'll dictate. Magnitude of the total load for the entire loaded length of 10 meter is equal to half into 10 into 16 kilonewton. Down. See, that will be somewhere here. This is the magnitude of the total load. See, this one for entire loaded length. Light line here. This will be 1 by 3 of 10. This will be 2 by 3 of 10. Now further. And right here, line of action of this load will be at 1 by 3 of 10 from A and 2 by 3 of 10 from B. See, now we want from both sides. But second half, when I do the special Q, you want moment about only Q there. Okay, right. Then, moment of that total load about A equal to first total load. Half into 10 into 16 is the total load multiplied by, from here, 1 by 3 of 10. Answer not required. 10 clockwise kilonewton meter. This way. Now, if you want moment about B, once again you are right, below you are right, moment about B. Same total load into not 1 by 3 into 2 by 3 of 10 anti-clockwise. These all, if you are not serious, you don't write all these separately, you will have trouble later. The purpose is not served. Then, moment of this total load about C. See, I can do it equal to here finger. Total load same into 3.1 plus 1/3 of 10. 1/3 of 10 clockwise. Lastly, moment about the point D. If you write 4 times here equal to same total load, moment about this point is 2.8 plus 2 by 3 of 10 anti-clockwise, right here. Up to here is already over earlier. If difficulty is there, refer part 3, case 1, A, question number, B, question number B. Over. Now, right, when everything is over, come here. Now, purpose of this class. A point will come in between. Where? Anywhere. Let the point Q be at 10 meter, 10 meters, okay, 4.2. At 4.2 meter from A. From A. Now, I have to prepare the diagram. I remember the values there. I note it down. 10 and 16. Otherwise, I will forget later. Okay. Start now. I told a point Q at 4.2 from A. Neat sketch. See, 16 here. Total is 10. I not written here. You know it. Now, see at the point Q, let intensity be W suffix Q. You should write, let W suffix Q be the intensity at Q. Then, similar triangles, you should stand here. If this is 4.2, that is 5.8. Stand here. 16 divided by 10 equal to W suffix Q divided by 5.8. You get W suffix Y Q, not X actually. W suffix Q equal to 9.28 kN per meter. Enter the answer. Now see. This side you get trapezium. That side you get triangle. Therefore, I will first go to that side. Later, when you consider loading to right of Q, very, very happy case. So better look that side if option is there. See here, magnitude of the total load here. See, written here, equal to half into 5.8 into 9.28 kN down. Line of action from here is from Q, 1 by 3 of 5.8. Therefore, moment about Q equal to total load half into 5.8 into 9.28 load into 1 by 3 of 5.8. This way, very easily you get the answer. Okay, turn this side now. Or when we consider loading to see left side, left of Q, see the face here, left of Q. Then moment of this load you require. This total load will be acting somewhere here. Light line, magnitude. Let the distance of that load from here be X bar from Q. Okay. Remember, first, magnitude of the total load equal to this area 16 plus 9.28 divided by 2 into 4.2. kilonewton. Down. Line of action is set from here. See, we want line of action from Q. 9.28 plus twice of 16 divided by 9.28 plus 16 into 4.2 divided by 3. Now, this total load multiply by the distance, you get the moment. This already over earlier. Okay, now that side will remain same. Left side, make a note. First of all, I should not give it. Now, everything is over. Now, left side, you continue further or write one more sketch. Then remove this x bar all. You write one more sketch. Write one more sketch. Loading, okay. That is what to do. See. Divide into a rectangle and triangle. I 1000 times told. Rectangle means UDL. So now, if you want, see, here light line. This is UDL. This is UVL. Okay, now, this total load will be here. This distance is exactly center. This total load will be somewhere here. From Q, this distance will be 2 by 3 of 4.2. Now, very important, see, this is 9.28. You can write here. This is 9.28 kN per meter. And this is not 16. Now, 16 gets cancelled. 16 gets cancelled. The remaining is 16 minus 9.28. 16 minus 9.28 is, calculator is not on. 16 minus 9.28. 6.72 kilonewton per meter. You calculate 6.72 kN per meter. In the pencil you write here. Now, I'll tell you. Magnitude of the total load considering left side is this UDL, that is 9.28 into 4.2. You should write it if you are serious. I can't tell every time. I am dictating not for fun. 9.28 into 4.2, that is down, plus one more load, this triangle load, half into 4.2 into 6.72. Half into 4.2 into 6.72. That also down. Add these two, you will get the same total load we got last time. Then, with magnitude. Now, M is moment of this total load about Q. See, you should write about Q equal to, first, this total load. 9.28 is the intensity into 4.2. Or if you want, you can write 4.2 into 9.28. But I prefer intensity first for UDL because same practice. Okay. Multiplied by that load is acting here. This distance is half of 4.2. That is anti-clockwise. Plus one more load. This triangle load. Half into 4.2 into 6.72 is the total load multiplied by, from moment about Q you want, from here to here is 2 by 3 of 4.2. That also anti-clockwise. When you go to bending moment, sorry, I will not tell now. I told already, not telling. Right now it is like this, anti-clockwise. Over. This will complete example. Which one? Example, I forgot to tell one thing, already over. Example 3, then subdivision 1 dot over. Now subdivision 2 dot. There also two cases, subdivision 2 dot. 2 dot is right uniformly varying load represented by an isosceles triangle. Okay, I'll do one thing now. I'll first finish that one now. Then I'll prepare that point Q. Some explanations are there. 1 minute. I'll remove now. Because this is not important. It's already over. Okay, now, right. Example. This will come later. Example 3, 2 dot. 2 dot A. Not A, no A, only one case. uniformly varying load, you can write represented by an isosceles triangle. Means what? This way here, this way here, this way here. Let it be A, let it be B, some outside point here, C and D, that is not important now. Imagine entire loaded length is 12 meter. 12 meter, and correctly this distance and this distance are equal. Why equal? Isosceles triangle. Same, both are equal. This intensity is say 20 kilonewton per meter. This distance randomly take 4 meter, randomly take 3.8 meter. Okay, now I'll first finish. Write everything. First you write the sketch. Then start solving. When you start solving, then write one more sketch. Right. First, see. Considering the entire loaded length of 12 meter, you should write, see, first half is for entire loaded length. Q will come in the second half. Considering, you should write entire loaded length of 12 meter, magnitude of total load equal to half into 12 into 20 kilonewton. Kilonewton down, over. And line of action of the total load, because it is full load from A to B, it's the isosceles triangle, it will exactly pass through center here. See, this is that magnitude I wrote is here, magnitude. That is at 6 meter from here, 6 meter from here, over. Then next, moment of this all I am not writing because it is already over earlier. This is a recap. Moment of this total load for entire loaded length of 12 meter about A, about here. About A equal to, okay, total load. Half into 12 into 20 is the total load, multiplied by, from here to here is 6 meter, over, clockwise, kilonewton meter. Next, below write moment about B. Once again the same total load, same distance, but it is anti-clockwise, kilonewton meter. Okay, now, moment about C. Same total load, but into, from C1, 4 meter outside, 4 plus 6 meter, or 12 by 2, clockwise. Moment about D. Same total load into 3.8 plus 6, or 12 by 2, anti-clockwise. Right here. Up to here, already over earlier. If difficulty is there, see part 3, case 2. Case 2, correct? Yes, part 3, case 2. Now, right, purpose of this class. Suppose we consider a point, say Q, somewhere in between the loaded length, between A and B. And for some reason, we want magnitude of the total load and moment about that particular point, where you take in between of considering loading only one side. Now, here, Q, about Q, let that point be Q, here, let that point be Q. Further right here, we will consider two cases. This is subcase. We will consider two cases, not two cases, 2 points. 2 points, say Q1 and Q2. Somebody will ask, sir, why 2 points? Reason is there. 1 point on this side, 1 point on that side. Somebody has asked me earlier, suppose the point is here. If the point is here, cannot you do it? Yes, we can do it, sir. Sorry. Okay. Now, I will take Q1 at 6 meters there. This is 20 by 6. At trapezium I want bigger. At 1.5 meter, 1.5 meter from A. And Q2 I will take at 1.8 meter. 1.8 meter from B. See, Q1 I will take at 1.5 meter. This is 1.8 meter. 1.8 meter. And remember, both of them separately or solve one by one. Both independent. Both independent. I will do it, no problem. Okay, start. Now I will prepare. This much I am struggling and explaining. What is the purpose? To give maximum knowledge. Still, so many people are not going to full class. They look as if this is an entertainment class. Not their choice. I know one fine day, people will start referring more and more. Okay. Now, that point is not there about Q. Now come to important part. Come today's class. We will consider 2 points. I already told you. 1 point I told from left end at 1.5, left end of the loaded length from A, 1.5. Second I told earlier 1.8. I changed my mind because when I took 1.5 and 1.8, I got 5 here and 6 there. Both are round numbers. I want decimals. So I am changing. The second point is not 1.8. You change it to second point at 1.95 meter. I want a fraction meter from B. I want from B 1.95 meter from B. Second point from B. Oh, okay. Both you should take independently. Okay, right here. First, consider Q1. First, consider Q1. Q1. Okay. Draw a neat diagram. See, this total is 6 meter. This is 6 meter. Here, this point you take E. See, this is 6 meter. They don't see 1.95. 1.95 will come in second round. I am telling only Q1. Our Q1 is here. Here 1.5. When this is 1.5, this total is 6 meter. This is 4.5. Now, let the intensity be WQ1. You show the calculation. WQ1 divided by 1.5 equal to 20 divided by 6. By similar triangles, WQ1 get 5 kilonewton per meter. Okay, now, if you consider left side here, just one triangle. Therefore, suppose you are doing shear force bending moment here, it is advisable to look left side because there you have to look only one side. But in case you are forced to look right side, then right side we got a trapezium and also a triangle. So what to do? Therefore, what to know is, see, dot, 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 dot. Right side is full dot, 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 dot. Right here. This is a triangle here. This is trapezium. So if I look left side, total load equal to half into 1.5 into 5. Line of action will be, you write here, no space. This will be 1 by 3 of 1.5. So moment will be the total load into 1 by 3 of 1.5. I wrote here, anti-clockwise. More important is right side. See, if I look right side, this triangle. This triangle is for, you write here if you want. This is the total load from B up to E. This is the total load from Q1 up to E. This is a triangle here. This is 1/3 of 6. That side not required. From, if you want from this side, this is 1/3 of 6. This load be at X bar Q1. Now remember, X bar Q1 equal to 5 plus twice of 20 divided by 5 plus 20 into 4.5 by 3. This all explained for you infinite times. Therefore, calculate total load. From here I will start. Half into 6 into 20, one load. 5 plus 20 divided by 2 into 4.5 is second load. Add these two, you get total load that side. Then moment about Q1 of this side. Half into 6 into 20 is the load into 4.5 plus 1/3 of 6 clockwise. Then 5 plus 20 divided by 2 into 4.5 is the total load into this distance is 5 plus twice of 20 divided by 5 plus 20 into 4.5 by 3 clockwise. Now make a note. Those people who are afraid of trapezium, if you practice from my class, you will not be afraid of trapezium. See, if you thoroughly practice everything from me, why should you be afraid? Okay, trapezium. For them, what to do is, see here, correctly. Remove this one. Left side you are not seeing. Left side already over. See, left side already over. See here. Then be careful. This is 5 kN per meter. This full is 20. Do one thing. Safer side, you 20, you write here. Otherwise, problem. Where I'll write here? Okay, I'll write somewhere here. See, here I'll write 20 kN per meter. That is for this full triangle. For this triangle, somewhere here, light line right here. This already known. How much? 5 kN per meter. This ordinate will be pencil mark. This full is how much? Oh, I forgot the full height only. Luckily I remember. See, 620. Luckily I remember. Full is 20. This is 5 means this is from 20. 20 there, already there. 15 kN per meter. If this is not clear, subject cannot be taught. Now, total load, if you look right side, is this triangle load, same as last time, no change, same as last time, plus this rectangle load and this triangle load, this rectangle load. 5 into 4.5. 5 into 4.5. This also down, plus half into 4.5 into 15. This also down in kilonewton. Moment about Q1 equal to half into 6 into full 20 into 4.5 plus 1/3 of 6. That will remain same, plus that is clockwise. 4.5 into 4.5 is the total load, UDL. 5 into 4.5 UDL into, it will pass through center. See, 4.5 by 2. This all you should thoroughly know it. Then plus once again, half into 4.5 into 15. Half into 4.5 into 15 is the total load into, see, that total load will pass somewhere here. This from here to here will be 2 by 3 of 4.5 into 2 by 3 of 4.5. This also clockwise, all clockwise, over. This is what to do if you are afraid of trapezium. Okay, now Q1 point over. Now we will come to second point, Q2 at 1.95 from that side. So that, see, I cover each and everything. So everywhere in the entire course, nothing will be left out. If you study from me thoroughly, you will get surely unlimited knowledge. This I am telling from beginning only, not from now. Start now. Second part. Now consider Q2 somewhere there. Consider Q2. I already told 1.95 from here. Then this will become 4.05. This will become full 6. WQ2. 20 divided by 6 equal to WQ2 divided by 1.95. WQ2 equal to, I do not want mistake actually, 20 by 6 into 1.95. 6.5 kN per meter. Okay, enter it. Now, look right side, only triangle. But if you look left side, oh, one big triangle of 6 meter base, a trapezium of 4.05 meter base. So I will do one thing now. I will first finish right side because see, space is not there. Smaller return. Magnitude of total load. Magnitude of the total load equal to half into 1.95 into 6.5 down. Moment about this point, the total load into 1 by 3 of 1.95. Further, if I explain, you will feel bored. Some will tell. Same thing he tells again and again, 1,000 times. Okay. Now, consider left side. Be careful. If you look left side, now we got total load. See, this triangle from A to E, total load will be somewhere here. Remember, distance from here will be 1 by 3 of 6. And trapezium, total load will be somewhere here. Distance from Q, let it be x bar Q. X bar Q, Q2. X bar Q2. Now it's not Q1, Q2. Start. Remember, this is 1/3 of 6. This how to find x bar from here. It is told so many times. From here, I will tell now only. 6.5 plus twice of 20 divided by 6.5 plus 20 into 4.05 by 3, told infinite times. Okay. Total load, half into 6 into 20 plus 20 plus 6.5 divided by 2 into 4.05. This is a triangle area, that trapezoidal area, over. Moment about Q2. Half into 6 into 20 is the total load into 4.05 plus 1/3 of 6. 4.05, it's not clear written there. 4.05 plus 1/3 of 6, anti-clockwise. And this load, I told you, area of the trapezium, 20 plus 6.5 divided by 2 into 4.05 into this distance, I already told 10-15 times. You get moment. Now, make a note. Anybody who is afraid of trapezium, now right here. Oh, I should not have rubbed the first one. Okay. First one remains same. Okay, no problem. What is there? Now right here. Or those people who are afraid of trapezium, when you look right side, no problem. When you look left side, this is a triangle only. Here, what you do? Remove this one. Light line, divide. Now remember, see, this very, very important. This ordinate is 6.5. I want this ordinate. Light line, project here. Somewhere right here. See, this is right here only. This is 6.5 kN per meter. Okay, now from here to here, see, this ordinate is 20 minus 6.5 is 13.5, correct, correct, 13.5 kilonewton per meter. Now, don't write 20 there, you write here, 20, you come this side, because confusion. Somewhere here you write, this full is 20 kN per meter. For this triangle, height is 20. For this triangle, height is 13.5. For rectangle, it is 6.5. Okay. Now, start. Total load. First, this load, same as last time. Half into 6 into 20. Already ordered. Down. Plus, there is a UDL here. See, UDL. Intensity is 6.5. 6.5 into 4.05 UDL plus this varying load half into 4.05 into 13.5. This is the total load. It will come same as last time. Okay, now moment about Q2. This load into this distance will remain same as last time. See, that will not change, but other will change. Plus this rectangle 6.5 into 4.05. 6.5 into 4.05 is the total load into, it will act through center. See, exact center here, half into 4.05 by 2 plus once again half into 4.05 into 13.5 is the total load multiplied by this varying load will pass somewhere here. Now fill this side, see, it will pass somewhere here. So from here, this distance will be 2 by 3 of 4.05 into 2 by 3 of 4.05. I think it is also clockwise, no, anti-clockwise, all anti-clockwise. Over. I think I just check the camera. Is the last portion visible or not? Visible, okay. Now, this is over. I will continue now for example 3 dot. UVL represented by a triangle in general, neither right angle triangle nor isosceles triangle, randomly. There one side more length, one side less length. That I will fully prepare and write. Start now. Example 3, third question, 3 dot. Subdivision A. I will tell you why subdivision A. Consider a uniformly varying load represented by a triangle in general. You can make a statement. Neither right angle triangle nor isosceles. A is here, B is here. Maximum is 9. This side is 6, that side is 8. Consider two outside points. Okay, now total loaded length is 14 meter. Now you should write, considering the entire loaded length of 14 meter, you should write it. That is full load if you consider. I told you the resultant load will pass on that side. See, if you consider separately, that is something else. If you consider the entire load, both sides together, line of action of resultant will be that side where length is more. So 8 meter here, it is more here, somewhere here. This is for what? This is full load. See, full load. Okay, start. Magnitude equal to half into 14 into 9 over. Now distance, see right here if you want. This distance from here will be length, full length 14 plus this cut length 6 divided by 3. And if you want distance from here, light line right here, here, full length, this all I explained earlier, plus cut length 8 divided by 3. Okay. Now, moment about A. Total load, half into 14 into 9 into this distance, 14 plus 6 by 3 clockwise. Moment about B. Same total load into 14 plus 8 by 3 anti-clockwise. Moment about C. Same total load into 3.1 plus 14 plus 6 by 3 clockwise. Moment about D. Same total load into 1.2 plus 14 plus 8 by 3 anti-clockwise. Okay. Now do one thing. Make a note. where is the eraser? Here. Now make a note. By chance, you find difficulty for this L plus A by 3, L plus B by 3, those formulas, two triangles together somewhere on the higher side. If you got difficulties there, what you do is you consider this load and this load separately, right here. So I'll put dot, 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 dot. These two loads separately. See, here hatch if you want. Okay, now, then for this side load, line of action is here, total load. This will be from here 2 by 3 of 6. From here 1 by 3 of 6. For this one, resultant load will be somewhere here. From here, it will be 1 by 3 of 6. From here, it will be 2 by 3 of 6. You make this note. Now write. Magnitude of the total load equal to half into 6 into 9. That is a downward load plus one more load, half into 8 into 9. Downward. Get the answer. Now, moment about points you want. Okay, write one by one point. Now, moment about, I'll write here, moment about A. See here. This load, half into 6 into 9, this all already over earlier. That's why I'm doing fast. If it's something new, I will not do this fast. Multiplied by, from here to here is into 2 by 3 of 6. This distance, or I'll do one thing, space problem, moment about A, space problem, about A equal to, see, half into 6 into 9 is the triangle load, this side, into 2 by 3, moment about A, 2 by 3 of 6 into 2 by 3 of 6, that is clockwise. Again plus one more, half into is a load, half into 8 into 9 is next load, into moment about this point, 6 meter plus 1 by 3 of 6. Clockwise. Both are kilonewton meter. Moment about A. Okay, start. Moment about B. Don't do this way, I will explain. Okay. Moment about B. This load, half into 6 into 9 into 8 plus 1/3 of 6. And this load, half into 8 into 9 into 2/3 of 6. 2/3 of 8. This is not 1/3 of 6. 1/3 of 8 it is. I think just now I wrote how much here? Moment about A, how much I wrote? Okay, I write once again. No. I think by mistake, I took 6 meter, I think here. Okay, I write once again. No, I do not want any mistake in my class. Okay. Load about A. I write once again. No mistakes in my class. About A is half into 6 into 9 into 2/3 of 6 clockwise plus one more, half into 8 into 9, that is called a misprint actually, into 6 meter plus 1/3 of 8. 1/3 of 8 clockwise. Okay, I corrected it. Now, moment about B. Half into 6 into 9 into about B is 8 plus 1/3 of 6. 8 plus 1/3 of 6 anti-clockwise, and one more load, half into 8 into 9 is next load into directly 2/3 of 8. See, directly 2/3 of 8 anti-clockwise. Next, moment about C. Half into 6 into 90, 9 into 3.1 plus 2/3, about C here, 3.1 plus 2/3 of 6 clockwise, plus half into 8 into 9 into 3.1 plus 6, then further 1/3 of 8 clockwise. Over. Last point, moment about D. I write first. Start. Moment about D. Half into 6 into 9 is the load into 8 plus, 1.2 plus 8 plus 1/3 of 6. See here? Then half into 8 into 9 is the total load this side into 1.2 plus 2/3 of 8. Remember, all these up to here, all these already over earlier, part 3, case 3A. See the class over. Now we will go to that point Q. Before that, I should make a note. See, now when I rub the board, when I come back, I may forget what was the dimensions. 1 minute. I'll write somewhere here. One side 6, one side 8, 6 and 8 and 9. Sufficient for me. That's sufficient for me. One side 6, one side 8, right 9. Now I will do one thing. 2 points I will take. 1 point Q1 here, 1 point Q2 here. It is already over last time. I will once again explain. But next question, see, that is when left side is more, right side is lesser, the dimension different. 100% same as this question that you have to solve. I will give a problem here with answer. That time you have to calculate, correctly make a fair copy, and then calculate the answer. It should tally with what I am going to give. I will be extremely careful when I give the answer. Okay, I will prepare for that one. 2 points, Q1 and Q2. Last part for this time. Now, what do you have to do? Now come here. Now, purpose of this class, etc., all you write here Q, but we will consider 2 points. Earlier one, sometimes 2, because 2 parts are there. Q1 and Q2. Q1 at 1.6 from A and Q2 later, not now, after this finish, after Q1 is over, at 2.4 from B. Okay, we'll see later. Start. First, consider Q1, where I written here, Q1 is at 1.6 meter from A. So from A, 1.6 meter is the point Q1 here. See, this is your Q1. Now, start. 9 divided by 6 equal to WQ1 by 1.6. You will get 2.4. If that much you cannot calculate and show the calculation, I can't tell anything for that one. Okay, over. Now, make a note. This already over earlier. If I look left side, I get simply a triangle. So, better look left side if option is there. But if you are forced to look right side, you got one big triangle here of base 8 and one trapezium of base 4.4. Start. Left side, I wrote simply, no space here. See, magnitude of the total load. Magnitude of the total load considering loading to left of Q1 will be, see, this load. Half into 1.6 into 2.4 down. And this distance will be 1/3 of 1.6. So moment will be that total load into 1/3 of 1.6. So this is very, very easy. Okay. Or if you consider right side, actually I told you better left side, because when you do bending moment calculation, you consider any one side. But sometimes you are forced to consider that side. In that case, don't get panic. Okay, start. Total load. See, this triangle load is here. This will be acting at what distance? 1/3 of 8 here. Here, one trapezoidal loading. This from here to here, let it be x bar q. Okay, start. Now I should not explain. Total load. This load, half into 8 into 9. This load, 2.4 plus 9 divided by 2 into 4.4 is the load. Then, moment about this point. This load, half into 8 into 9 into 4. Finger is at Q1, 4.4 plus 1/3 of 8. This way, and next, once again, one more load, 2.4 plus 9 divided by 2 into 4.4 is the load into this distance is 2.4 plus twice of 9 divided by 2.4 plus 9 into 4.4 divided by 3. Explain endless number of times. Get the answer. First of all, I should not have done all this one. I should have given only directly answer. Okay, now, or, once again, see. That is there. Or, right here, this side is not required. Leave it. Or, when you consider right side, people who are afraid of trapezium, see now, that will remain same. See here. Who are afraid of trapezium. Now, this side is not required, this is not required. Remember, there is a rectangle load here and a triangle load here. See. This load is acting here, center. This is acting at 1/3. See. This will act at 1/3 of 4.4. This will be at 4.4 by 2. Now, very important. See, we require this ordinate. This height, that height is, how much it is? Oh, I forgot that answer. Oh, I can calculate also, no problem. I can calculate also, forgot that number. It is not there. Okay. What is there? Who will remember all those? 9 divided by 6 into 1.6. 2.4. Okay. This ordinate is 2.4 kN per meter. And remaining height, see, for this triangle, remaining height is, this height for this triangle is 9 minus 2.4 is 6.6 kilonewton per meter. R into, correct. Okay. Now, don't write 9 here. That 9 you write here, so that no confusion. Okay. Now, see, total load. This load remains same as last time. Half into 8 into 9 plus this rectangle plus how much is 2.4 into 4.4. That also down. Down plus one more, half into 4.4 into this height is 6.6. That also down, over. Moment about Q1 equal to this load into this distance will remain same as last time, plus all clockwise now, this moment, 2.4 into 4.4. 4.4 is the total load into, we want moment about which point? See, we want, we want not that distance. We want moment about Q1, so we want this distance. See, Anyway, this is same. This is 4.4 by 2 only, but this distance will be changing. See, total load is here. We want moment about Q1, so this distance will be 2 by 3 of 4.4. Okay, now write here. 2.4 into 4.4 into half of 4.4, that is clockwise, plus once again half into 4.4 into this height is 6.6. 6.6, the total load multiplied by 2/3 of 4.4. 2/3 of 4.4, that also clockwise, over. You calculate that answer, this answer, both will come same. Okay, now Q1 over. Now we'll do one thing. We'll consider Q2. Q2 at what distance I told? 2.4 meter from B. 2.4 meter from B. From B. Okay, I think I'll write once again the sketches now, because rubbing here in front of you means it will take more time. Dirty, I'll clean it also. Now come to Q2. I will briefly explain. See, Q2 is here, 2.4 from there. This is full 6 meter. That 8 meter, this is 2.4, this is 5.6. Okay, start. 9 divided by 8 equal to this ordinate divided by 2.4. Get the intensity. By chance, if any calculation mistake is there, I am careful, you ignore it. You learn everything. Start now. If you consider rights, this is the best one. See, now considering right is better. I won't write anything, waste of time. Total load, half into 2.4 into 2.7. Magnitude, moment about Q2, half into 2.4 into 2.7 into 1 by 3 of 2.4. Waste of time explaining. Left side, considering moment, this side, total load, one triangle, half into 6 into 9, one trapezium, 9 plus 2.7 divided by 2 into 5.6. Moment about this point. Half into 6 into 9 into 5.6 plus 1/3 of 6, and this load 2.7 plus 9 divided by 2 into 5.6 into, from here I want 2.7 plus twice of 9 divided by 2.7 plus 9 into 5.6 by 3 is the answer. Told endless number of times. If I explain, somebody in front of me, they will object. They will tell, sir, this is too much. Okay. Now, or right here. Or right here. Or. People who are afraid of trapezium, for them, okay, that side you are not bothered now. See, that side never bother. Okay, don't bother that side. Here, what you do? If you are afraid of the trapezium, see, this is one load, this is other load. Now, this will remain same. This load will act to center, this will act here. This will be exactly half, 5.6 by 2. This distance will be 2 by 3 of 5.6. Then your right side total load equal to half into 6 into 9 plus this rectangle UDL 2.7. 1 minute. Before that one, what you have to do? Before that you have to do one thing. See, this for this rectangle you mark ordinate here. How much here? 2.7 kN per meter. For this triangle, mark ordinate here. How much it is? From 9 subtract 2.7. It is a 5.3, correct? Correct, 5.3. It is 5.3 kN per meter. Remove this one. Okay. Now remember, for this rectangle, 2.7. For this triangle, 5.3. And if you want a full triangle here, it is 9 kN per meter. Now total load equal to half into 6 into 9 plus, I written here, plus half into 6 into 9 plus intensity 2.7 2.7 into 5.6 down plus one more half into 5.6 into 5.3 this side 5.3 that also down. Calculate. Moment about Q2. When you want moment about Q2, this load into this distance will remain same as last time. No change. Plus change will come here. 2.7 into 5.6 is the total load. 2.7 into 5.6 is the total load into center 5.6 by 2 plus this is anti-clockwise again plus 1 again half into 5.6 into 5.3 half into 5.6 into 5.3 is the total load into moment about this point 2/3 of 5.6 anti-clockwise. Calculate the last time answer, calculate this time answer, both will come same. Over. Now this is completely over. I will do one thing now. Now I will do one more question. See. This I will do one thing now. This is completely for you. I will not tell anything now. This question. After solving all these questions, if you cannot do it, then I should pass very hurting comment. Okay. See next example. Example 3 dot, correct? 3 dot, case 1, case 2, correct. And B question. See, direct answer. Now, this side is more, this side is lesser. Now, this is A, this is B, this is E, this is on the, I'll take a round number, easy to calculate. 60 kilonewton per meter. This base length I will take, this base length I will take 10 meter better. Okay, 10 meter. This base length I will take 8 meter. 8 meter. And okay, this is the road. A point C here at 2 meters from here and a point D here at 1.5 meters from here. Okay, start. First, what is already over? I will keep on giving answer for you. Keep on giving answer for you. Okay. Now, completely homework or you practice. See, for me, actually if you want only answer, I can do fast, but I should somewhat explain what I am doing. Magnitude of the total load for, forgot, entire loaded length of 18 meter. Entire loaded length of 18 meter is half into 18 into 60. 540 kilonewton. I'll write here. 540 kilonewton. Then moment of the total load about C, about A, about B, about C, first about A, usually first about A, moment about A, moment about B, moment about C, moment about D. If you remember, if you consider total load here, the line of action will be, this side is more length, it will be here. See, I told you, this distance will be 18 plus cut length 10 divided by 3. If I write from that side, that will be 18 plus 8 divided by 3. This is all I told you. So calculate moment about A. Total load is 540, correct? Half into 18 into 60 is 540. 18 plus 10 divided by 3 into 540 is 5040. 5040 kilonewton meter clockwise. Moment about B. Half into, 540 into the total load into 18 plus 8 divided by 3 is 4680. 4680 kilonewton meter anti-clockwise. Moment about C. Half into 18 into 60 into 2 plus bracket 18 plus 10 divided by 3 is 6120. 6120 clockwise. Moment about D. 540 into bracket 1.5. It is 1.5 meter. I think it should be visible for you. 1.5 meter. Okay. Otherwise, some will mistake it some other instance. Tell answer is not telling. 1.5 meter. Okay, 1.5 into bracket 1.5 plus one more bracket 18 plus 8 close divided by 3 is 5490. 5490. Now I can check the answer some other way. This is anti-clockwise. About A I got 5040. 5040 plus 5040 plus total is 540. 540 into 2. 6120. Correct. About B I got 4680 plus 540 into 1.5. 5490. Correct. Tally. Over. 100% correct. Now, this is if you do directly considering entire loaded length. But suppose you have difficulty or that this formula difficulty is there, then consider this load separately and this load separately. Then total load half into 10 into 60 plus half into 8 into 60, you will get same answer. Moment about A. This load into 2/3, that load into 10 plus 1/3. Moment about B. This load into 8 plus 1/3 and this load into 2/3. When you want moment about A, this load into 2 plus 2/3, this load into 2 plus 10 plus 1/3. This load into 1.5 plus 8 plus 1/3, this load into 1.5 plus 2/3, you get the answer. Okay. Up to here, right here. Up to here, already over earlier, refer part 3, case 3. Part 3, case 3, over. Already over here. Now, new part. Remember, now you should write all these things. 3 points I want. Okay, I won't waste time. I'll do it here only. Who will write again and again? Because it is somewhat exercise for you. You should work out. See, this is for you to do. Okay, now, 1 point I will take. Now consider 2 points, Q1 and Q2. Q1 I will take, this is 10 meter, Q1 at 3 meter from A. Q2 I will take at 8 meter, 2 meter from B. Okay, now see, first consider Q1. So where 2 meter from here, I want more space here. Q1. Not 2 meter. If I take 2 meter, this will come 8 meter. No, I want 3 meter, sorry, 3 meter. This is 3 meter. This will become 7 meter. This will become 8 meter. Now, this 18 meter gone, C and D gone. 1 minute now. I may forget later. 60. At this side is how much? This side is 10. That side is 8. From this side I want distance 3 meter. From that side I want 2 meter. Okay. I'll forget later. Okay, now start. This intensity you require. WQ1. 60 by 10 is 6. 6 into 3. 18 kN per meter. Why calculator for that one? 18. 60 by 10. 6 into 3. 18. Okay, now, look this side. Total load. And moment about Q1. Moment about Q1. About Q1. Or this is this side. Or look that side. Total load and moment about Q2. Q1. Right here. Wait, correct. Wait. little more and right. Total load, if I look left side, right side, and moment about Q1. There. Total load and moment about Q1. I'll calculate. If I look this side, total load is half into 3 into 18, 27 kilonewton. Direct answer I am giving. Moment about Q1 is into 1. Or that also 27. 27 kilonewton meter. If I look right side, see, one trapezium and one triangle. For trapezium, it is this total load into this x bar distance, this triangle into 7 plus 1/3. Okay. Then, later, if you are afraid of trapezium, this way. This is 8, remember, this is 8. This is 10. Correct? This is 18. This is 18. This is 42. 42. 60 you write here. 60 you write there. Okay, now this is not required now. Take moment about Q1. You can take either trapezium or whatever you want. I will take trapezium. I am not afraid of any 18 here. This is 60 here. For me, no problem. 18 plus twice of 60 by bracket 18 plus 60 into 7 by 3 is the distance into bracket 18 plus 60 divided by 2 into 7 is the moment plus half into 8 into 60 into bracket 7 plus 8 by 3. Moment is 3447 kilonewton meter clockwise. Total load I forgot now. Total load is 18 plus 60 divided by 2 into 7 plus half into 8 into 60 is 513. 513. I can apply a small check. This side load is 27. That side load is 513. Total is 540. Correctly tallying. Then I can apply one more check now. When you want moment about Q1, for this side load, moment is here. This is anti-clockwise. That is clockwise. You don't bother about it. I am checking it now. If I combine those two, I will get 27 minus 3447. It will come 3420. It will come 3420 anti-clockwise. How to check it? For the entire load, 3420, correct? 3447 minus 27. 3420. For the entire load, you don't bother what I am doing now. Moment about Q will be total is 540. This is 18 plus distance is 10. 10 divided by 3 is 9.83. Minus 3, I subtract 3 multiplied by 540. 3420. Perfectly correct. What I did, you never bother. What I did, you never bother. Answer is 34, perfectly correct. Okay, now, closing part of this one, another point. Okay, to save the time, I will put one more sketch. Now Q1 over, now consider Q2. Okay, closing part. This time, I won't explain anything. Why this much over? If someone wants explanation, he is not fit to study. It is 8 meter, 10 meter, this is 8 meter, little more. Okay. This time it is entirely for you. Okay. This is A, this is B, and our point is Q2 at 2 meter from here. See, this is 10 meter. This point is E. Our point Q2 is here. How much from there? 2 meter. If that is 2 meter, this will become 6 meter. So this intensity you require. This is how much? 60. See, I forgot how much, but luckily visible there. Otherwise gone case. 60 kN per meter. 60 by 8 into 2. I think 1/4 I think. 60 by 8 into 2 is 1/4. 15, correct. This will come W at Q2 is 15 kN per meter. Okay, now answer. If you look right side, total load and moment about Q2 is clockwise. If you look left side, total load and moment about Q2, answer will be anti-clockwise. Okay, direct answer. This time, see, you will get a trapezium here. When you look left side, if you can manage trapezium, take trapezium. Or, see, you know it, rectangle, triangle. How many times over already? So total load equal to, that side is half into 2 into 15. 15 kilonewton. 15 kilonewton. And 15, moment is half into 2 into 15 into 1 by 3 of 2. 1 by 3 of 2, correct. 10 kilonewton meter. 10 kilonewton meter. If I look left side, total load, half into 10 into 60. 10 into 60 plus bracket 60 plus 15 divided by 2 into 6. Something wrong. Half into 10 into 60 plus bracket 60 plus 15 divided by 2 into 6. 525 kilonewton. 640 total. Yes, 525. Correct, because both sides together is 640. Correct, tally. Moment about this point is 15 plus twice of 60 divided by 15 plus 60 into 6 by 3 is the root into bracket 15 plus 60 divided by 2 into 6 is moment of that load plus half into 10 into 60 into bracket 6 plus 1 by 3 of 10. 3610. 3610 anti-clockwise kilonewton meter. Now I will check this moment. How I will check the moment, you don't bother. Moment about, I will apply some other trick. So I will tell you if I want. See what I will do, I will tell you if you are serious. See, moment about Q2 you want, see. This way. Actually not required for you. There is a point called Q2 here. I will find moment of the entire loading about Q2. Entire loading, resultant load is how much? 540 kilonewton. Distance from here to here will be, you never bother this one now, 10 plus 6 by 3, and from here to Q2 is 2 meter. So this will be 10 plus 6 by 3 minus 2. So 10 plus 6 divided by 3, some answer minus 2 into 540, I will get 1800. Huh? Something wrong. Something wrong. Moment about Q2 is half into 10, half into, how much it is? 18 into 60. 540 is correct. 10 plus, that is 8 meter. Oh, this is 8 meter here, not 6 meter, 8 meter. Oh, see, mistake. 10 plus 8 divided by 3 is 6 meter. If it is 6 meter there, subtract 2 meter into 540 will give me 2160. 2160 now. 2160, but I am getting 3610. I think I have to check the answer once again. I have to check once again. One nimisha. Q2 is where? 2 meter. Total load distance from here is 10 plus 8 by 3 from there. Okay, no problem. Don't worry. 8 by 3 from that side is 6 meter. Subtract 2 meter, 4 meter. 540 into 4 is 2160. I am getting 2160. 5 my check. But then this is wrong. Okay, check once again now. Moment from that side. Half into 2 into 15 into 1 by 3 of 2. 10, correct. That is a 10 clockwise. This side. Oh, I think this triangle I have not taken, I think. Correct. See, this is wrong. Because 15 plus 60 divided by 2, 15 plus twice of 60 divided by bracket 15 plus 60 into 6 divided by 3 is the distance into bracket 60 plus 15 divided by 2 into 6 is the moment of that one, 810 plus half into 10 into 60 into bracket, that is 4 meter, 4 or for other 6 meter, 6 meter plus 1 by 3 of 10 is 3610. Again coming 3610. Correct answer. Then how it came 2160 here? Total load is acting this. This is 10, this is 8. From here 10 plus, oh sorry, not 10, 18. Oh, span is 18 meter. What I am doing? Okay. See, now it will tally. 18 plus 8 divided by 3 into 540 is 4680. 18 plus 8 divided by 3 is this full distance. Subtract 2, that is that distance, into 540 is 3600. 3600 is the anti-clockwise moment. I got 3610 anti-clockwise, 10 clockwise. When you add those two, you never bother. You will get back 3600. See, sometime it happens. Number problem. See, I took 10 meter. It is 18 meter span. That is because usually, when I am taking non-stop classes, see, I am talking non-stop for some time. Some such thing happens, but I never get a panic. See, never 1 micromillimeter panic for me. I know answer has to come. No question can escape from me by giving wrong answer. Impossible. Maybe calculation mistake, observation mistake, what I can do for that one? Human being. Okay, now this is over. Now, lastly, example 4. Once again, A and B, uniformly varying load represented by a trapezium. One systematically I will explain. Other one, like this question, I will give exercise for you with answer. I will do one thing. I will prepare the answer before the in front of you. I won't calculate because when the original sketch is there, easy for me to prepare the answer. When you make this construction solve, distance are not visible. Okay, you never bother. Checking is my problem. Example 4a, you can write uniformly varying load represented by trapezium. Example 4, A because left side lesser, right side more. Next question, full homework for you this way. Okay, start. This is 20, this is 35, everything is given there. Loaded length 8 meter. I should make a note because why? Usual chance of forgetting. See, that chance of forgetting. Once I finish, I will rub the board. 20, 35 and 8. Okay, sufficient. Now, those who can see now, first what you do? First you consider the entire loading for full 8 meter. That is already, I am explaining what is already over earlier. Okay. If you take full trapezium, total load will pass here equal to area of the trapezium. If you want distance from here, it is how much? You know, I write here if you want 20 plus twice of 35 divided by 20 plus 35 into 8 by 3 if you want from here. If you want from here, it is from here. You should not write actually, to understand I am giving 35 plus twice of 20 divided by 35 plus 20 into 8 by 3, just to understand. That is your x bar. Okay, now everything is over. Total load magnitude. How much? 20 plus 35 divided by 2 into 8 is the total load. I wrote here. Line of action, I already told you. Moment about A. The total load into this distance. See, written here, clockwise. After A, I will do one thing now. I will first go to C because easy for me. If I go to C, total load into 2 plus that distance. See, that's why I want C. Over. Again clockwise. Now, moment about B. That's sorry. What I wrote just first was about A. This is about A. Okay. Once you finish copying A, then write moment about C. Then write 2 plus. Okay. Otherwise, some will tell still A is there. Okay, then moment about this, moment about B. Same load, but this will interchange. What will happen now? From that side, this is not there. Total load into this distance, 35 plus twice of 20 divided by 35 plus 20 into 8 by 3 anti-clockwise moment about B. Suppose you want moment about D. This load into 3 plus this distance. Over. Now, for those right here who find difficulty for trapezium, what they'll do? They should do one thing. See now, right? Or people who find difficulty for trapezium, see. This is 20 kilonewton per meter. This is 35 was there, 15 kilonewton per meter. This already over earlier. I am actually wasting time. Kilonewton per meter. Now do one thing. I will not dictate. I will not write. I will dictate. Okay. But before that one, see, one load here, one load here. This will be at, this how much? It is 8 meter. This will be at 8 by 2 and 8 by 2. This will be 2/3 of 8. Actually, this way fast I am not doing, but how many times I have to explain? This is 1 by 3 of 8. Now, see, write systematically. Total load 20 into 8, rectangle, half into 8 into 15. That's all. You should get the same answer. Moment about A, 20 into 8 into 8 by 2 plus half into 8 into 15 into 2/3 of 8, you will get same answer. When you want moment about C, same thing, you add extra 2 meter plus that one. Moment about B, 20 into 8 into 8 by 2, anti-clockwise, half into 8 into 15 into 1/3 of 8. Okay, get the answer. When you want about D, same load and distances, distance you add 3 meter extra. Okay, answer will come same. This is told plenty of times. Now remember, make a note here. Why I told so fast and without explaining? Because already up to here already over earlier, refer part 4A. Part 4A you refer. Okay. Those who are serious will refer. Those who are not serious, let them do whatever they want. 8, 20, 35. Okay. Now, closing part of the question. Almost over. Because I decided to upload today. It's already late night now. Okay. I will do one thing. I will write and explain. Because it will take more time. Let the board get little dry. I will prepare and explain. Because now it is a problem for you. Start now, second half. Now write all the statement. Okay. Something happened there. Camera moved, I think. 1 minute. Okay. Actually, the wire got pulled. Suddenly I got afraid. Okay. Now, write all the statement. One point Q required. I will take it 3.6 from A. So total is 8 meter. That side is 4.4. Now I will not explain much. Those of you who are not afraid of trapezium, see. Those of you who are not afraid of trapezium, left side you look. Now see, this time what happens? Whichever side you look, amount of work is same. There is no easy way. If you look left side also trapezium, right trapezium, before that one, you require intensity here. Here 20, here 35, total length 8, increase for a length of 3.6, or from there, decrease for 4.4. Get this answer. This is by linear interpolation. If anybody got difficulty for linear interpolation, you should go to my channel, go to playlist. There is a playlist there called long, around 2-3 years earlier uploaded, mathematical concept. There, class number 3 is very, very powerful class for interpolation. Not only for this one, that interpolation class is for entire structural engineering. Even some RCC part also is there. And therefore, go there and get. Don't tell me I am not getting his answer. Interpolation. Okay, now, see here. If you look this side, resultant load will be here. If you look that side, resultant load will be here. This I will call X bar from Q. This I will call X bar from Q. Okay, or you put left side. Okay, XL left side, XL bar Q, XR bar Q. XL means X bar for left side portion from Q, X bar, some symbol, what is there? See now, I will tell now. This load, 20 plus 26.75 divided by 2 into 3.6. I wrote here, left side load. And line of action is this distance is from here, 26.75 plus twice of 20 divided by 26.75 plus 20 into 3.6 by 3. That's how I got moment here, see. Or if I look this side, total load, 26.75 plus 35 divided by 2 into 4.4. Moment means this distance. That sum of the total load into this distance is 26.75 plus twice of 35 divided by 26.75 plus 35 into 4.4 by 3 is the answer. This you already know it. Now, right here. Or those people, everything is already over. Therefore, someone will surely tell. Okay, now, or those people who are afraid of trapezium, be careful. When you look left side, see here, be very careful. When you look left side, I will put full white red dot. Right side, I will put black dot. Remove this one, remove this one. Draw one more sketch. Then, see. This way. And there, see, there, this way. So here, left side is, see, one rectangle here. And one triangle here. Right side also, see. You write one more sketch for understanding purpose. You are not losing. If you write everything, you are not losing anything. One rectangle here and one triangle here. Now, this is 26.75. This full is 35. So, this distance will be, see, this distance is, this is 26.75. 75 kilonewton per meter. And that distance is 35 minus 26.75. 35 minus 26.75 is 8.25 kN per meter. 8.25. I think it is not out of camera. Most probably I will check it. If it is out of camera, I will move the camera. 8.25. It is small I am writing. See in the laptop. Okay, that's all. Now, here, this will be, see, this intensity is UDL 20 kilonewton per meter. And this intensity, that is, this height is 26.75 minus 20 is 6.75 kilonewton per meter. 6.75 kilonewton per meter. Now, total load, see, this load will be back to center. This will act at 1/3, 2/3. From here, 1/3. That much you are knowing now. This rectangle will be at center. Triangle will be at 2/3 from here. See, this is at, see, this is, be careful. This triangle is at 1/3 of 3.6. But that distance is at 2/3 of 3.6. Not 4.4. 2/3 of 4.4. Be careful. 1 minute. Check the camera. Has it moved? If it moved, I will. No, everything is perfectly okay. And now, there is nothing there. I will conclude now. Considering left of Q, see, now fast I finish. Magnitude of total load equal to 20 into 3.6, 3.6 down plus half into 3.6 into this height, that is 6.75. If any calculation mistake is there, correct it. And moment about Q we want equal to this load 20 into 3.6 UDL multiplied by center 3.6/2, that is anti-clockwise. Once again, half into 3.6 into 6.75 into this distance is 1/3 of 3.6. See, this is 1/3 over. This is also anti-clockwise. Compare the answer with the last time, direct trapezium formula. This side, magnitude of the total load equal to 26.75 into 4.4 UDL or rectangle plus half into 4.4 into 8.25. Any calculation mistake, check it. Down over. Moment of this total load about Q, red color I will not use, about Q equal to rectangle load 26.75 into 4.4 is the total load into midpoint of rectangle 4.4/2, that is clockwise, half into 4.4 into 8.2. I am telling still by mistake, if any calculation mistake is there, correct it. Principle is important. Into, see here, into 1/3, but here into 2/3. Why? This triangle, see 0 here, this is 1/3. This triangle is 2/3. Into that much you can make out. 2/3 of 4.4 clockwise over. Now, this over. Now, lastly, example 4B. I forgot. If any doubt is there, you refer for earlier one, 4 part A. Okay, now here, 4B. This is only answer, question and answer. Question and answer. No explanation, nothing. But one important, I will tell you, little later I will tell. When I come to that one, I will explain. Okay. I will prepare I will do one thing. Instead of checking again and again, I will silently bring the calculator here. I will apply my I will do the calculation first, write the answer, then I will tell you. See, because anyway it is a question job. Okay, now concluding part of this class. See, now uniformly varying load from left side, right side is decreasing. Okay. I will not tell in hint. Those who have got capacity consider full trapezium, total load 380 kilonewton, moment about A 1700 kilonewton meter clockwise, moment about B 2100 anti-clockwise, moment about C 2840 clockwise, moment about D 3810 anti-clockwise. It took me only half minute now. Just now I paused the recording. Okay, now this is over. Remember, up to here, already over earlier, difficulty means refer part 4, there, question number B. Okay. Now point Q. I will take Q at 4 meter. I took an easy point at 4 meter from A. From A. Okay, start. 4 meter from A point here. This is the point Q. Now 10 meter is gone. This is 4 meter. This is 6 meter. Now 3 and 5, 4.5, tell get out. Get out. You require intensity at Q equal to 40.4 by interpolation. Kilonewton per meter. Interpolation. Okay. Now, those who got capacity consider total load to left side. I will answer first. Answer is there. I will put the on meet. Where is the right time? I am not getting it. Where I put it? Okay, some here. Moment about total load is 380. I require for checking purpose 380. Okay. Total load 380. Okay, sufficient. Anything else required? No. Nothing required. No. Okay. Those who got capacity consider trapezium full. Full trapezium. Only thing is the board is little wet. It should get dried up. Otherwise, it won't write properly. Got it. Okay. Now, direct answer. If you look left side trapezium, just now I explained. If I look right side trapezium, just now I explained. So, answer, if you look left side, considering left side of Q, we want total load and moment about Q. Or considering right side, we want total load and moment about Q. Okay. Total load left side is here 180.8 kilonewton. I know already calculated. This trapezium area, that side 199.2 kilonewton. That trapezium. This moment will come anti-clockwise of 374.4 kN meter anti-clockwise. Right side moment will come 554.4 kilonewton meter clockwise directly. Now, those who are afraid of trapezium, do one thing, see here. Now be careful. Last time, remember, see, for this triangle 1/3, that triangle 2/3. No. Now this time, resultant is here. This side is 2/3 and that side is 1/3. Distance is all you decide. Now, I will conclude the class. This class you have to go through as many times as possible. Practice everything. I will guarantee you will have complete mastery over SFD, BMD and in structural analysis. Now, as usual, I give an answer. Check I will do here. I am not afraid to check now. 1 minute, not a big issue. Moment about Q. Okay. If you want moment about Q, I will find moment about Q of the left and right I got. Complete loading, if I take moment about Q, it will be, this centroid is at I got centroid. that centroid distance. I will subtract from where is the load. I will subtract from how much? Subtract from 6 meter. I will got the distance 0.47 something. Where is the point Q? 4 meter, correct? It is a shift store B, 5.52 meter from there. Minus 6 will give you 0.47 something. 0.47 into total load is 180.8. And what is total load? Total load where? Total load is not 180.8. Total load is 180.8 plus 199.2 is 380. Okay. I wrote here 380. See, don't worry what I am doing. I will locate line of action. No, not beyond your capacity limit. Some of you may feel bad. What? We are also good. Okay, be good. I am happy. 6 minus shift A2 is the distance of CG into 380. I will get a moment of 180 kN meter, 374.4 and 554.4. I got 180 clockwise. 554.4 minus 374.4 is 554.4 minus 374.4. Perfectly 180. Therefore, answer given is 100% correct. Nobody can tell this answer is wrong. Okay. Now, just you should think how much patience and effort I have put to all this. If you think that much, then surely you will study. Okay. There is one more information I want to pass. I am seeing not much views, maybe some because of I am not going for publicity. See, I don't go for any publicity, but if views are very less, the motivation will not come. Therefore, those who see all this up to here and listen to me, some may not come here, I know it. Do one thing, you spread my education channel to as much as possible so that when you get more views and more response, I feel motivated. Otherwise also I am feeling motivated only. Even if one person is there, I will be serious. But you know, to the mind, that feeling will come. Oh, my class is viewed or used so many places. I will be happy actually. That is, teaching satisfaction will be there. That is ultimate for a teacher, not money matter. Money comes secondary. This I am telling right from earlier. Of course, money is important, no doubt. But it is secondary. First is always subject and education. In Kannada, we call it Vidyadana or Vidya. In Hindi also it is Vidya only, I think. I don't know what is that one. English education. Okay. Thank you. Next class I am starting support reaction. Actually, from now onwards, it will be more serious. Support reaction is very critical for structural engineering. Okay. Thank you.